Namaskar and a very pleasant warm greetings to you from DELNET Developing Library Network, New Delhi and TERI School of Advanced Studies, New Delhi. It's a profound privilege for us to welcome you all to today's DELNET and TERI SAS joint collaborative webinar, which is on best practices for building green campuses. It's a profound privilege for us to have each one of you with us today, this afternoon. Distinguished speaker, Dr. Aviruch Bhatia, Assistant Professor, TERI SAS. Mr. Ratan Kumar Jha, the Assistant Librarian TERI SAS and the Webinar Coordinator, officials from TERI SAS, heads of various institutions who have joined us this afternoon, institutional administrators, librarians, library and information science professionals, faculty members, environmentalists, officials working for green initiatives, students, DELNET officials at Delhi, Bangalore, Hyderabad, and Pune. Ladies and gentlemen, I, Sangeeta Kaul, on behalf of DELNET and TERI SAS, extends a very warm, hearty welcome to each one of you for joining us this afternoon on Best Practices for Building Green Campuses webinar. Each one of us are fully being aware with the fact that what green campuses can do wonders in the life of an institution. And all of us are here today, are being assembled today in this online platform to speak about that what are the best practices which are being followed, which should be followed in the institutions for building green campuses. We have with us this afternoon a very profound speaker and a distinguished speaker, Dr. Aviruch Bhatia, who is an assistant professor at TERI SAS, and he's the domain expert who is going to share his vast expertise with us this afternoon. We extend a very hearty welcome to you, Dr. Bhatia, and thank you very much for joining us this afternoon, and thank you very much for acceding to our request and being there with us. We are indeed much grateful to you for your very, very kind, gracious presence with us this afternoon. Also, on behalf of DELNET, I would like to express our very sincere thanks and appreciation for Mr. Ratan Kumar Jha, the Assistant Librarian at TERI SAS, with whom we have got a wonderful association of past nearly more than 15 years. And we are appreciative of the efforts being made by Mr. Jha, along with his entire library team and other officials at TERI SAS, for making it possible for DELNET in joining hands with TERI School of Advanced Studies in organizing this very special webinar on best practices for building green campuses. We welcome you, Mr. Jha, and thank you so very much for putting in your best efforts in having each one of us here today. I would also like to acknowledge that we have received an overwhelming response from not only different nooks and parts of the country, but also from many other countries. So we have with us today our attendees who have joined us from various diverse backgrounds, and all of us have something in common, and that is all of us are keen enough to be a part of Green India movement, to become an integral part of the movement, to bring in, to look and see everything green around. And today is an effort in sensitizing our own selves that what are the best ways in building up the green institutions in the country and to make the country more greener. And green, all of us are being aware about it, that always denotes and symbolizes prosperity. We are pretty sure that these deliberations today would lead to more meaningful interactions in the days to come. I would, at the very outset would like to request Mr. Ratan Kumar Jha, the Assistant Librarian at TERI SAS and also the Webinar Coordinator, to kindly extend a welcome on behalf of TERI SAS and also on behalf of DELNET yet again. It's over to you, Ratan.
Thank you so much, ma'am, for your nice introductions, and always I impress your this initiative. And once again, thank you so much. Whatever this we have today, the webinar, the idea behind you, everything, we just call a phone, and within a day we have decided we are going to have this kind of webinar. And as far as TERI School of Advanced Study concerns, we are practicing. We are not teaching, even we are practicing day-to-day life. the green initiative kind of things. We have most of our programs related to energy, environment, and sustainable development, and we have our more than 3,000 students pass out till date, and more than 2,000 PhD scholar defense in our this Santun's campus. We have started in 1998, but we have shifted this green campus 2008, and we are practicing the same. So once again, thank you so much, ma'am. So we have jointly started these programs first time with the DELNET. DELNET have a vast network on and members. So they must got the advantage of these associations. In future also we will get the associated and do the same kind of program webinar or different topics. So they all are benefited this time. Today the day of our faculty colleague, a faculty member, Aviruch Bhatia day. They will tell you and there was the detail about the green campus or green building and what we have practices in the campus. So same will detail explain you. Over to you, ma'am. From my thank you so much once again for your introductions, and thank you so much for everything what you have provided to us and services the DELNET has provided to us. Always all the faculty members, students very glad to always requested the resources from the DELNET. So DELNET is not providing nowadays resources other than they are doing lots of things DELNET are doing to us also. Thank you so much, ma'am, for this kind of association. And for future we'll carry on seeing. And over to you, ma'am.
Thank you. Thank you so very much, Ratan. And thank you so much for being such a wonderful professional colleague for years, and also for your very sincere work that you have been putting in always for your users and also for the DELNET's member institutions. You have always been very, very supportive, and we truly, truly acknowledge that. Thank you so very much indeed. It's now a profound privilege for me to introduce our distinguished speaker of the day today, Dr. Aviruch Bhatia, who is an assistant professor at TERI School of Advanced Studies, New Delhi. Let me share with you that DELNET and TERI SAS, we are also the immediate neighbors. We are just across the road, and it's a wonderful opportunity that we are getting connected online and getting, having in collaboration between the two organizations who are also located physically in the very closer proximity. So it's a pleasure for us to having the program here today with TERI SAS, who's also a distinguished member institution of DELNET for more than a decade now. Dr. Aviruch Bhatia, who is serving as an assistant professor at TERI School of Advanced Studies, deemed to be University, Delhi. He has a PhD in IT in Building Science from International Institute of Information Technology, Hyderabad. His areas of research interest includes building physics, building performance simulation and analysis, and green buildings. He's a certified Griha trainer and IGBC-AP. He has 3 years of experience at AECOM, where he worked on a variety of green building projects, performed simulation and analyzed results to help project design teams to select buildings parameters to optimize cost and achieve targeted credits for green building certifications. It's a profound privilege for us to have you with us today, Dr. Aviruch Bhatia. Thank you so very much once again for sparing time for us and in being there with us today at this very prestigious webinar, which is on best practices for building green campuses. I would also like to mention that even the accreditation bodies like NAC are fully realizing the importance of building up the green campuses, and that's the reason they have also have included it in their own NAC handbooks. You can see that they are asking the institutions whether the institutions have adopted any best practices for building their green campuses. I think there are going to be many takeaways from this webinar. I don't want to stand between you and our distinguished speaker of the day, Dr. Bhatia. I have profound privilege in welcoming you, Dr. Bhatia, once again, and would like to request you now to kindly start the deliberations of your wonderful talk that all of us are really eagerly looking forward to. It's over to you, Dr. Bhatia.
Yeah, thank you very much for the kind introduction. My slides are visible and I am audible.
Perfectly fine.
Perfect. So today we are going to talk about best practices for building green campuses. So we will start with what are the problems with buildings because buildings consume energy, water, material, and we want comfortable conditions inside. And for the, as suggested in accreditation council also, we need to show green building features. So that my presentation is on this line only. So building stock is continuously rising because there is a rapid urbanization and people are moving from villages to urban areas, and demand for the building stock is continuously rising. And buildings consume about 35% energy in total. So if you can see this breakdown here in India, this breakdown is for India, taken from Energy Statistics 2020, and consumption of electricity by sector. So you can see here industry consumes 41%. After that, we have this domestic and commercial sector. These are both building sectors. So about buildings are consuming 34% energy. And buildings also consume 40% of raw material globally. Fresh water consumption is there, CO2 emissions are there, and 90% of the time we spend indoor. So that should be comfortable also. And to reduce this resource consumption, India is committed at COP26 2021, and as per India's commitment, 50% of our energy needs through renewable by sources by 2030. And we also need to achieve net zero carbon emissions by 2070. To achieve this, we need to construct our green buildings. We need to adopt green building features. And how we define this green building? A green building is a building that in its design, construction, or operation reduces or eliminates negative impacts and can create positive impacts on our climate and natural environment. Green building preserve precious natural resources and improve life quality. So green building is not only for saving energy or water or material. This is also to bring healthy living conditions inside our building. And generally campus buildings are also important because students study in this campus. So these green buildings, if we are making, it has both tangible and intangible benefits. These tangible benefits are the water use reduction, energy use reduction, but intangible benefit include health and well-being of students and faculty and other staff. So it includes enhanced air quality, excellent daylight, and other conditions. And generally, a green building, we generally have 5 major areas that include energy, indoor air quality, materials, site, and water. And it will give us healthy, comfortable, durable, energy efficient, environmentally responsible conditions. So let us start with energy efficiency. So these energy efficiency features in building we can show with passive design, because nowadays because the outdoor temperature is rising, we are using a lot of air conditioning system. That is, we call it HVAC, heating, ventilation, and air conditioning system. So the passive and low energy design systems can minimize the hours where we actively using air conditioning systems. So these passive design features that we can adopt are window shading, that include overhang, fins, blinds, window to wall ratio, selection of glass, orientation. There are other methods like earth air tunnel, stack effect, chimney that can be adopted, and lighting system related measures can be adopted in building, and there are various HVAC system related measures are also there. Let us start with in passive features, windows. So generally we use single glass window in our building, but if we replace that single glazed glass with the efficient high performance single glazed glass, or we can make the double or triple glazed glass. In double glazed glass, we can fill either air can be air filled or inert gases can be filled. So the replacement of glass with a high performance glass can lead to a lot of savings, because the glass has three main properties that are, we call it visible light transmittance, solar heat gain coefficient, and thermal transmittance of that glass. So we are in India is in tropical climate, and we always want to restrict heat transfer, because in India we have outdoor at 40 to 45 degrees Celsius, and inside we maintain, let's say, 26 degrees Celsius. So there is a delta T, and whenever there is a delta T, there is heat transfer, and we don't want heat to come in, because it will lead to hot warm condition inside and the increased use of air conditioning system. So we need to restrict U value to the lower, and solar heat gain coefficient, that is the direct sun radiation we are getting, we want it to be lower, and visible light transmittance we want as high as possible, because the main purpose of windows is to bring daylight, visible daylight, useful daylight for us. So in Indian conditions, the U value and SHGC should be lower, and visible light transmittance of window should be higher. So here is the total spectrum of solar radiation that we receive. So we are interested to in this visible. So there is ultraviolet, visible, and infrared. So this visible portion of this spectrum is useful for us, because that can be used for the day visual activities. But this infrared and ultraviolet, this causes the heat, and our aim should be to reduce these portions. So there are especially a high performance glass is available to minimize this infrared part and to maximize the visible part. And window to wall ratio is also important. So we can see in Western world, in where climate is cold, they use large windows in their building, but that copying that same architecture or that kind of window to wall ratio in India is actually not recommended, because we are having different warm climate and we want to reduce heat gains. In Western world, in cold climate, they want to increase heat gains because there is heating energy consumption, but here we have cooling energy consumption, so we want to reduce. So window to wall ratio is your, let's say this is your wall, so total wall area, and this is window we have, let's say, so this is a window area to wall area. So in Indian condition, even energy conservation building code has the cap about 40% window to wall ratio is there. So we can use different simulation tools to find out what is the optimum percentage of windows we can provide in our building. So you can see this chart. So how this chart is varying, if there are no windows in our building, what will happen? It will be completely dark, and we are going to use interior lights. But if we have windows, that means we are getting some daylight inside our building, and our use of interior lights are limited now. So that's why this energy consumption will come down. But after a certain percentage, our all interior lights are switched off. And if we are increasing window to wall ratio, again energy consumption will rise, because whatever the heat gains we are getting from windows, it will lead to increase in energy consumption of air conditioning system. And also with the different type of the glass, if you are using single glaze glass, then it is a lower, and if you are using better glass, double glaze glass, or actually 90.1 equivalent glass, then we can get this inversion at the higher point also. So instead of having the full glazed walls, if we are limiting our window area in building, or we can say that optimizing it, then it will really helpful to bring more and more daylight and save energy. And we can also reduce energy consumption for lighting system. We can have efficient lighting fixtures. We have efficient light LED lights, we can use it. We can have the daylight controls, we can have occupancy controls. So daylight controls helps us whenever there is a daylight available. It will automatically switch off interior lights, or it can dim also. It can adjust interior lights. That will lead to saving in energy consumption. And also occupancy sensors, when there are no occupants, we can switch off some portion of the interior lights. So this is how we can save energy. These are green features like installing daylight controls and occupancy sensors and reducing lighting power density can help us to save a lot of energy. So here is the one article published by researchers. So they have demonstrated it in university building. If we install motion detection system and room management system, we can save about 30% of energy can be saved. Classrooms daily electricity consumption. Now we'll come to the equipment and appliances. The best is the switching off. Switching off or enabling power down mode reduces energy consumption, heat produced by equipment, which turns to lower cooling rate. So whenever equipment is not used or not being used, we can switch it off. Upgrading existing equipment, some energy efficient appliances may cost more to buy, but it will recoup saving over the lifetime of equipment. Like we have now BE has a star rating system. So if we are using star rated fridge, star rated fans, star rated equipments, so initial cost might be slightly high, but on the long run in operating conditions, we can save energy. And matching the equipment, the task, bearing in mind current and predicted requirements, and taking advantage of labeling schemes that are available. And whenever the appliances are not used, it is better to switch it off. For example, the computer, generally we won't shut it down, we just hibernate it and keep it like that. So if a computer left overnight for a year, it creates enough CO2 to fill a double-decker bus. Because so these are the ghost power. We are not switching it off. Then also in hibernation mode, also a computer system consumes some power. And we also use photocopier machines in our campuses. The photocopier machine left standby overnight waste enough energy to make 30 cups of the tea. So it is recommended whenever the appliances are not in use, it's better to switch it off instead of keeping it standby. A daylight design is also green feature, because for the visual task we need daylight, and daylight can help to save energy, because if we are getting sufficient daylight in our building, we can switch off our interior lights, and we can save energy on not only in lights but also the on air conditioning system. It can help to increase the aesthetics, and it can also increase our human performance, the psychological and biological benefits. So this is the one of the study in USA. This study was done for the daylight classroom and without daylight classroom. So 21,000 students test score were analyzed. So it was found that if we have the good daylight in our classroom, students perform better, 20% faster than a math test and 26% faster in the reading test. So there are a lot of benefits. So if we work in without window environment, and if we work with the environment where we have the sufficient daylight, our performance is generally increased with because in daylight give the psychological and the biological benefits. And also the views are important. If we are able to see the outdoor conditions, if we are connected to outdoor, this will give additional benefit. And thermal comfort is also one of the features in green buildings, and thermal comfort generally depends on these 6 parameters, that is air temperature, mean radiant temperature, relative humidity, air movement, clothing ensemble, and metabolic rate and activity. And so why thermal comfort is important in green buildings? Because if we are thermally comfortable, our productivity for the work is increases, and also it is related to energy, because the set point generally we maintain for air conditioning system. So generally uh, we maintain about 23-24 degrees Celsius in air conditioning spaces, and if we increase the set point by just 1 degree Celsius, we can save about 4 to 5% cooling energy saving. So how we decide what set point we should be maintaining? So instead of 24, if we 24 degrees Celsius, if we set our set point to 26 degrees Celsius or 27 degrees Celsius, whether it is giving comfortable conditions to us or not. So that 6 parameters that we discussed about thermal comfort plays a role. So we can set temperature at the higher with use of ceiling fan, because air movement is also one of the parameter. So instead of switching off fan, run fan at the lower speed and increase set point. It will give us the same comfort conditions. And also these comfort conditions are dependent on mean monthly outdoor conditions, outdoor temperature. So in New Delhi, so here you can see this is for New Delhi, and New Delhi has the mean monthly outdoor temperature about 33-34 degrees Celsius. So our comfort conditions are at the highest set points compared to someone is living in the Stockholm, where mean monthly outdoor conditions are at the 16 degrees Celsius. So we can feel comfortable at about 31 degrees Celsius also. So it is not like we need to set our set point at 22 degrees Celsius and cool that room is too much. We can increase set point with slightly increasing the air movement by switching on fan. So by doing this, we can save a lot of energy. And whatever the measures, how much we can put in our buildings. So first is to bring the measures by which you can decrease energy consumption, and the rest of energy that you are not able to save, we can install renewable energy generation systems like a photovoltaic or small wind turbine that can be installed to generate green energy, because the energy that we are getting from grid is most of energy thermal power plant, coal is consumed, and CO2 emission and GHG emissions are there. So if we are installing photovoltaic and wind energy system, these are the clean sources of energy, and we can generate it on site, and we can also invest in the off site. And here is a calculator from government is available to size the system. So how much roof area is available for installing, and so we can set here if it is institute, it's in Delhi, what is the electricity cost, how much roof area is available. Like in this example I have kept it's 20 square meter area is available, it's institute type of building, and this is the electricity rate we are paying. So by filling this information, it will also suggest us how much a power plant of photovoltaic power plant you can install, what will be the cost of power plant per kilowatt, what will be the energy generation, and what is your lifetime cost saving will be there. So you can visit to this solar rooftop government.in to find out how much PV you can install on your rooftops. And this is a one more green feature that we can adopt is the cool and green roof. So it is with the minimum investment, just what we need to do, paint our roofs with the white color paint, or the green roof can also be installed. So what is the benefit of installing cool roof? Because if you see, this is the dark roof. If we are getting solar radiation directly on the roof. Roof is throughout the day almost it is exposed to sun, and because of the roof sun's exposure, it will absorb a lot of energy, and its temperature is generally in summer, if you see, it's about 60 to 70 degrees Celsius, and the heat is conducted to inside our building, and reflection is very less. But if we apply cool roof paint, white color paint on roof, what will happen? Most of the radiation, about 70% radiation, can be reflected back. So this roof is absorbing only 30% and only few few heat gains are in the building. So you can reduce your air conditioning energy. You can bring thermal comfort condition inside if it is a comfortable passive conditions. So cool roof and the green roof are beneficial, not only in getting green points but also in saving energy. So this is the one of the study that I did, where we have actually measured in two parallel buildings, two same buildings were there, identical buildings were there, one with installed with the gray roof and other with installed with the white roof, and we measured how much energy reduction is there. So you can see here 12.7 to 12.7 megawatt hour cooling energy was saved annually with the application of cool roof in this particular building. And at the urban level, the urban heat island is a problem. So urban heat island is whatever the regular temperature is there, and at the city centers there is a higher temperature than the surroundings, that we call it the urban heat island. And to reduce urban heat island, one of the way can be, because parking spaces, it's a black or tar road and the vehicles are, if parked outside, it absorb a lot of energy and heat. So if we can if we can move parking to covered spaces, and these covered can be have the reflective panes or vegetated roof or energy generation system, it can help to reduce urban heat island effect. And regarding also in parking, if we can install electric vehicle charging stations. So nowadays electric vehicles are there, and so you can see electric charging point station if the car is there. So if we have the preference, those who are bringing electric vehicles, and we are providing with the charging station so they can charge their vehicles, it can help. And also keeping reserved parking for carpool, because if we are doing carpooling and van pooling, that can add, because we are reducing number of vehicles on road, which leads to the reduce CO2 and emissions, pollutions. So if we are giving reserved or preference in the parking for those who are coming with by carpool or van pool, it can add to the green feature. And night pollution reduction, this is also a site related parameter. So we have the different nocturnal birds, and if there is a light pollution in night, it is harmful for the nocturnal birds. So consider the location, surrounding areas during lighting design, select luminaires, location, orientation that minimize light trespass into adjacent properties. Aim fluid light angle low, that entire beam falls within the intended area and it's downward. Well shaded luminaires, and a couple outdoor lighting conditions with the lighting controls, motion sensors, and also if interior lights are designed such a way it won't go out of the building. That can help to reduce night pollution. Now we come to the water related efficiency, because if our buildings are green, then we can save a lot of on water, potable fresh water also. So by use of water efficient plumbing fixtures, ultra low flow toilets, urinals, waterless urinals, energy efficient low flow sinks, energy efficient dishwater can help. Water recycling or reuse material, methods to reduce water use in air conditioning system. So in air conditioning system also we use a lot of water, because in the central air conditioning system we use cooling tower, and this cooling tower, 1 ton of cooling tower per hour, it consumes about 10 liters of water. So huge quantity of water requirements is there. So if we are using the gray or recycled water, treated water for air conditioning system that can help to reduce freshwater requirements. In landscape features, irrigation and landscape measures, water efficient irrigation system, irrigation control system. So you can see here drip irrigation, if you can provide that, and if you can reduce the turf area, because in turf also we need a lot of water requirement, and native species if you can prefer, and xeriscaping, that species that are taking very less or zero water, that can help us to save water requirement for landscape. And creating a water balance can also help to understand where water is going. This is the sample water balance for one of the projects that I have done. So you can see here this is a supply water from municipality, and this water is going for mainly for domestic purpose and flushing purpose. And both water in this project we are collecting, and it is going to sewage treatment plant, and we are getting about this recycled water, and this recycled water we are again using for flushing. So here in this project we have the dual flushing lines. So some portion about 8.4 KLD that we are taking from fresh water, but remaining that recycled water we are using for flush, and irrigation water 6.4 KLD and AC makeup. So creating this type of water balance, we can understand if there is any loss of water or how much water we are using for different purposes. And rainwater harvesting, roof and non-roof, can be one of the measures. On the roof area we can install pipelines to collect rainwater, and we need to filter that rainwater, and then we can store in the storage tank, or we can use it for recharge of the aquifers. So you can see in one of the projects, roof water collecting tank, so they have 50,000 liter capacity of the tank, and it is again connected with aquifer for the groundwater recharge. So after water, there are some features related to materials are also there. Segregation of waste is one of the green features. So whatever the waste generated in our building, if we are able to segregate it, like in campus we have the paper is there, if we can use the, after taking the printouts, if one side is available for use, it can we use it for some other purpose, other side, so we can save on paper. And we need whatever the cardboards and other things, if we can recycle it, the dry waste and wet waste or metal waste, if we can separate it out and use it wherever it's possible, reduce, reuse, and this can be done. And school, because students are indoor, the dust-free environment is important, because that is related to indoor air quality, indoor environment quality or indoor air quality. So we can install permanent entryway system at primary direction of travel to capture dirt and particulate entering the building at regularly used exterior spaces. So wherever there is an entry system, if we can install some kind of dirt capturing system like grates or grills or slotted system, and regularly if we can clean, and we can also use the dust-free chalks to increase air quality. And there is a one more in green building, one of the feature is fresh air, because especially in schools and campuses, in classroom, occupancy density is quite high, and if there is 2-hour class and continuously sitting students are there, and then CO2 level will rise, and if there is a rise in CO2 level, that leads to drowsiness, eye irritation, inability to concentrate. These are all the adverse impact of CO2 levels. So we need to, what we can do, we need to have the fresh air intake. We need to supply with our air conditioning system, we can supply fresh air, or we can also have the operable windows there, so we can allow some fresh air to come in to keep trap on the CO2 levels. And these type of CO2 sensors are available. If we can install these type of CO2 sensor in class or highly occupied area and meeting room, conference room, so we can see if CO2 levels are going high, then we need to open windows or start fresh air, dedicated fresh air system. And volatile organic compounds. So the volatile organic compounds are the carbon containing substances, easily become vaporous or gases. It can found in the paint, coating and cleaning products. So in coating, solvent containing VOC assist in quality of application and drying. So that substance paint does not stick on surface. And these can cause respiratory and other health problem for occupants. When used indoor, they release into indoor atmosphere of gassing. It occurs over time. So we can use the paint that is with the low VOC. It's a fear like less than 50 grams per liter, or zero VOC natural paints we can use. And we can also use the product like in that having the lower mercury, reduced mercury contained in the products, like basically mercury free lamps we can use. We can use organic fertilizers and pesticide, the organic fertilizers and pesticides to reduce the health impact of school students and faculty. Organic fertilizers are those derived from animal or vegetable matter. Few example of it can be manure, vermi, compost, seaweed fertilizer, and etc. Green housekeeping. So use environmental friendly cleaning products to prevent chemical related health hazards. Housekeeping product including hand wash, soap, detergent, toilet cleaning solutions. And also because use of our air conditioning system and fire suspension system, we use HCFC and HFC refrigerants generally we use. So these are the ozone depleting substance. So we need to minimize or use refrigerant such that it has a minimum ozone depletion potential, ODP. So we have CFC, HCFC. So these we need to omit. HFCs 134A, 410, and nowadays in future refrigerants are also available where we are minimizing these. And also in the fire suspension system, it should be free of halons or any ozone depleting substances. Now we have discussed green features related to energy, site, water, indoor air quality, and materials. Now this is the case study. Now I am going to take. This is a Teri School of Advanced Studies in our campus. What are the green features that we have installed? So our campus is located in Vasant Kunj, New Delhi, and it is 2 acres of campus. And sustainability is key concept guiding the entire design. And we have this G+4, and we have institutional area, commercial and student hostels are there. And so building orientation and design. So building by the design, building is oriented in such a way to minimize direct solar exposure. So if our building is oriented minimizing towards east and west, so this is west and east. If more area is towards north and south, so this orientation is generally considered as the best orientation. And if our building is oriented in such a way, if this is east and west, more area is coming towards east and west, then we will get more direct radiation. So this building was designed in such a way we are getting benefit of sun angles to reduce our direct exposure to sun. And wherever there is sun, because for the daylight feature we need to provide windows. So windows are provided such a day it is perfectly shaded windows, and this shading is such that it is not blocking our views to outside. So this south facing wall, so you can see this south facing wall is exposed, and it is louvers are mounted at 35-degree angle. It will ensure that winter sun is let in. So in winter we are getting this direct sun inside, but in summer, because sun angle is at the higher side, it is blocked by these louvers. And the buffer spaces, so all classroom are provided with buffer spaces. So there is no direct solar exposure to rooms. So you can see the corridors are provided. So these corridors are helping to cut direct exposure of solar radiation. And daylight design. So all spaces are designed such a way they are getting sufficient daylight. So the lighting system, combined day lighting system and interior lighting system is designed such a way it is reducing 70% of lighting energy demand, and use of efficient window is helping us to reduce heat gain in building in summer and heat loss in winter without compromising the daylight integration. So you can see this is our view of library where all lights are switched off. You can see these are the interior lights and these are not on, these are switched off. And windows are designed such a way we are getting sufficient light inside our building. So occupants can read easily whatever the required illumination level is by the National Building Code of India. We are getting sufficient light without turning on interior lights. So we are saving not only on air conditioning system, but also direct benefit on the thermal, make the spaces thermally comfortable conditions. And we also have here in a very efficient air conditioning system that we have the variable refrigerant volume system with a high COP, and also the natural cooling systems we have. We call it earth air tunnel technology, where we are using ground as a heat rejection system and thermal mass storage. So this, by using this earth air tunnel technology, we are able to save 50% energy that is required for air conditioning system compared to conventional system. And thermal mass is also giving us 40% energy saving. So how this earth air tunnel system works, because generally the earth temperature, if this is the ground level and 3 meter below the ground, we have almost constant temperature. So let's say if outdoor condition is at 45 degrees Celsius, we can have about 20 degrees Celsius, 20 to 25 degrees Celsius, the ground temperature we have, because ground is an infinite sink. Whatever heat it's infinite sink, so we can reject heat. So what in the system, what we are doing, we are taking fresh air from outside that is at 45 degrees Celsius, and we are passing through earth. So there are pipes in earth, air is passing through this earth. This 45 degree air is now about 25 degrees Celsius outlet we are getting. Then we are having the chiller plant. If we are not able to get comfort condition, then we are using this chiller plant, else this air is directly supplied to our hostel rooms. So even when summer conditions, when outdoor is quite high, we are finding it, our hostels are comfortable about, so we cannot say it is maintained at the 24-25 degrees Celsius, but 28 degrees Celsius to 30 degrees Celsius we are able to attain with this earth air tunnel. So with the zero air conditioning system, refrigerants, we are not using this refrigerant, we are able to bring temperature down. And we also have a solar rooftop system. So we have the 48 kilowatt of solar PV installed and 5 kilowatts separately for R&D purposes. PV is installed. We also have the small, one wind turbine installed at our campus. And for the water management, to reduce water demand, buildings in the campus have been provided with low flow fixtures and the dual flush toilet lines. Low flow taps results in 25% saving in water use. And whatever the wastewater is generated in hostel building, we are treating it with sewage treatment plant, and rainwater runoff from the roof and site is we are using for recharging of aquifers. So the conclusion, so we discussed about different green building features that we can adopt in campus. These features are related to site, water, energy, indoor environmental quality and materials. These are the main green building features we can adopt, and how to make green campus. And we discussed the case study of Terry School Advanced Studies, that green features we have. So thank you very much. If you have any questions, we can discuss.
Thank you very much, Dr. Bhatia, for delivering such a highly exhaustive session on best practices for building up green campuses. And we are greatly impressed, the way that you have carried out the entire deliberations in such a very easy way, the complex things to do, but in such an easier way, which sounds like they're all achievable. All of us, you have really inspired each one of us, to become green professionals, to bring in, make our environments greener and greener. And your contributions today are greatly, appreciated and admired. And that speaks volumes of your commitment. That speaks volumes of your contributions that you have been making in this field. You have touched upon, and I think for everyone, for each one of us, wherever we are, in whichever environments we are being working in our institutions, for each one of us, there are a large number of takeaways. Even when I look at, certain things, to be done here at DELNET, I've already jotted, at least some 7-8 things that we can think about. Even you have cited such wonderful, simple examples, even of putting the set point for the ACs. Many of us, would not, you really feel like, putting it lower, the more higher the temperature you try to put it, but you have even shown it, you have truly reflected, with your research, adding it with the research, supporting it through the research, what the research says about it. And I think that has been really the high points, of your talk, wherein you have also shown even a small little examples that even if we, as in the institutions, all of us into the technology era, you keep your systems on overnight, and you keep even the photocopiers, for example, you may be using it, let's say for half an hour in a daytime, different time durations, but how many of us really keep it switched off? You have rightly shown that how many cup of teas, one can make it if you're going to, keep it in a switched off manner. And even it has been, I think, lot many, if I just jot down, there would have been easily around 50 takeaway, 50 points, the bullet points, that one can do it. And we at DELNET in, collaboration with TERI SAS may just come up after this post webinar. We would like to make a bullet point for the institutions and for all the institutions. It's not just simply for the attendees, but maybe perhaps, Dr. Bhatia, we would explore having a small little manual, for the institutions, that how to build up the green campuses. And we can have a bullet points, as you have said, even, for example, this, the roof paint, the cool roof paint. And, you have shown even a comparison between the gray paint and the white paint. White paint, yes, majority of us, we do believe in, we have been, but not many of us really knows that what difference even a grayish tone and a white tone can make a difference in. And even for this night pollution reduction that you have spoken about, that no one has thought about that, what's going to happen. And we are talking about the environment. It's not just simply seeing everything green around, but it's also to make it as an eco-friendly, we should be in complete harmony with the nature, with the environment. So even taking care of those night pollution reductions, these are day light controllers, the occupancy sensors and other things, but one can think about doing it. So thank you so much. Even the CO2 sensors, all of, means these are the very innovative ideas that basically you have shared today, inspiring each one of us. We can create a kind of, I think each one of our attendees would agree with me when we say we can create something that we can do it immediately. You need not to really look around and seek someone's support for that. There may be certain things that you may think about, yes, you need to have a little more hand-holding or a consultancy to be taken, but there are a number of things which one can, and those of the institutions who are now planning to build up something, you have shown an example, the case study of TERI SAS, which has been a proud recipient of the Greenest University and Research Institution Award. I would like to take this occasion to inform all our attendees that TERI SAS, to which Dr. Bhatia and Mr. Ratan belongs to, has been a proud recipient of Greenest University and Research Institution Award. It was a part of RTCC 2013 climate change, and that's a very unique recognition being given by an international body for the institutions who have really developed their buildings, in a complete conformity with the requirement of the day. That is, to make ourselves adopt, the best practices. Thank you so very much. There have been enormous contributions that you have made to each one of us, and we had today, with us in this platform, many of the institutional administrators who may like to really implement, and I'm pretty confident that many of them are going to really get in touch with you. And as a post-webinar, we would definitely be wanting that DELNET and TERI SAS to work on creating a manual for building up the green campuses in the country, wherein it would be something easy to adopt, easy to implement, wherein we can share, these best practices. And as you have very wonderfully have divided into various sections, and that on each section how one can think about doing it, this is just a beginning today, Dr. Bhatia, what I'm able to really assimilate, through your talk. And thank you so much. You hold such a great expertise, and 45 minutes and our time is not really adequate enough. But yes, indeed, we have make a collaborative beginning today by having this session and having such a person of great expertise and knowledge. And thank you so very much for sharing it, filling up the pots of learning for each one of us, and making each one of us inspired, truly inspired enough, to bring in these changes that all of us always wants to see around. But yes, you have inspired us also to really implement them and to become one of the most active participants in this entire green initiative. So thank you very much, Dr. Bhatia. With your permission now, we would like to make the floor open for questions. And we could see while you were talking, there have been questions coming in. And so firstly, I would just like to quickly take the questions which are posted in the chat box. Also requesting our attendees, you are most welcome, in order to ensure we have larger number of interaction with Dr. Bhatia and we make the best use of his distinguished presence with us today. Requesting you all, if you can post your messages in the chat box, that would be more speedy and faster. I would like to take a question, Dr. Bhatia, and this is coming in from one of our attendee, and the first question would be how to calculate institutions, buildings, water auditing. Water auditing, this is from Sheikh Mira, who is wanting to know how to calculate institution, buildings, water auditing. Are there any procedures in place for water auditing? Dr. Bhatia, you may be the best person to answer. This is from Sheikh Mira, one of the attendee, who is wanting to know, and hostel buildings. So she's wanting to know how to calculate institutions, building, water auditing, and also as well as for the hostel buildings.
Yes, so for water auditing, we need to install water meters, and it's best to create a water flow chart. So I have displayed in this slide this kind of water balance we can create. So based on the water meters, because whatever supply we are getting from municipalities, we know what is that supply and how much it is going for. So it is flushing tank, if it is their supply, so what amount of water is going in the flushing tank, what we are using for domestic purpose. Accordingly, whatever the waste we are getting, whatever the size is there, sewage treatment plant can be installed. Then again, where this water is going. So this is we call the water audit. So for that, we need to install different water meters, and we need to keep check on what quantity of water is flowing.
Thank you very much, Dr. Bhatia. Yet another question, and this is coming from Mrs. Smita Bhatia, who is wanting to know, how about, sir, using thermocol sheets as insulation on roofs or as a part of the false ceilings?
Yeah, this is a very good measure. I didn't show one in this slide because this is the measure that we generally use for the while constructing. So I try to keep the measures that we can adopt easily. So using the insulation materials it's a very good measure for our reducing energy consumption in building. Instead of like brick or concrete, normal concrete roof, if we can have some kind of insulation. So that can be also a very good strategy. The insulation materials, not only it is a thermocol, there are polyurethane foam is available, PIR polyisocyanate is available, there is a glass wool materials also available. And so it's always beneficial to install insulation shore side, like over deck, over roof, because we are getting roof getting heated. If we install over roof, that is more beneficial. But if there is a problem due to rain, because of the water, we can also install it under roof, and we can cover with the false ceiling and the gypsum board. Yeah, that is a very good feature, and it's really helpful. The combination of cool roof, green roof plus insulation, we can reduce heat gains of our building.
Thank you very much, Dr. Bhatia. This question is coming from LB Reddy Yanam, who is wanting to know, sir, for green buildings constructed with GFRG technology for a small college, is it achievable in less space roof technology? GFRG technology means he's wanting to know whether for green building constructed with GFRG technology for a smaller college, is it achievable, or can we do it in less space roof technology?
Yeah, so
GFRG technology, he's just wanting to know for a green building, is it for a smaller college? He must be belonging to the college with a smaller budget, so he's wanting to know how much achievable is it? Is it feasible enough for a smaller college to embrace this kind of a technology?
So whatever the material is there, if it is like construction phase, it's recommended to use insulation, because if you are using insulation, it can reduce heat gains, and you can lower down your HVAC design, because if you are having insulation, your air conditioning sizing can reduce. This is for design, and operation energy for the HVAC, it can also reduce. So overall, whatever extra money that you are putting for installing this insulation, it can be recovered. You will get easily payback of 4 to 5 years. That extra money you are putting for materials.
Dr. Bhatia, what is this GFRG technology? What is this GFRG technology? GFRG technology that he has spoken about. Perhaps we are not much aware. I just quickly would like to ask you, in your viewpoint for constructing a green building, what is a kind of a, in comparison when we talk about, because we are all having our institutions with us today, and in order to conceptualize, design, construct a green building in comparison with the usual construction that we do, how much of percentage of expenditure do you think one has to add on in comparison with the very usual buildings that we create? What is a kind of an overall additional percentage of total expenditure? How much would it be? Is it 10%, 30%? How much?
Yeah, the many projects I worked where some calculation I done. So about 5 to 10% the extra cost we need to put, depending on the how much measures or we are target we are attempting. So we are going for platinum or gold or silver rated, depending on it. 5 to 10% is extra cost generally we can occur for making the building green.
That's simply great. That's simply great to know. So it's something that one can, one can easily think about, especially while designing it.
Yeah, if budget is in crores, then this 5-10%.
Yeah, no, definitely. Yes. That's 5 to 10% also matters a lot. But from the government, I just want to know, since you are at the helm of affairs, from the government, we know about the subsidies which are being there for solar panels and other things. What are the subsidies which are being given by the government? If you can throw some light, especially for making these green buildings. Any special subsidies which are being offered, for any of these things that we talk about for making these green buildings in comparison, anything that we have, like for solar panels and all that, we all are aware that we do have subsidies which comes. But for anything else, do we get something?
Yeah, for green buildings, we don't have direct subsidy, but indirect benefits are there. So that energy and water we are saving, that is the benefit. But from government side, we have the faster clearance of forest, Ministry of Forest and Environment, for the different regions. Like in the Noida and Delhi, we get the extra FAR, floor area ratio. We can have that, but there is no direct subsidy or that kind of. Faster clearance is possible. Extra FAR is there. These type of benefits are there.
But yes, definitely at the same time, if we implement even a small little practices, if we bring in, I think, that would also help us in saving upon lot much of our, savings, means your expenditures would. So it's a one-time expenditure that you're making, but yes, that has got the everlasting effects that would be more recurring in nature. So the benefits would be more recurring then, yeah. That's great. That's great. So we're just wanting now to go to our attendees quickly, because we are just, about to heading towards the conclusion of the webinar session. Any of our attendees who may like to ask a question, please raise your digital hand. It would be a pleasure for us. Okay, this is being said by Mr. L.V. Reddy, who wants to convey to you, Dr. Bhatia, that they have Heatham in Hyderabad Institute of Technology and Management, and they are saying that it's the second green building campus. So they're wanting to share it with you. And okay, this is from Surajit Sanyal, Dr. Bhatia, and Surajit Sanyal says that, don't you think that reducing carbon footprint in every steps are essential? Your take on this, that reducing carbon footprints in every steps are essential.
Yes, it is very much essential, and to meet our goal that is promised by our Prime Minister, internationally our NDCs in COP26, we need to be we need to be net zero by 2070. So by 2070, every industry will be, we need to have a completely net zero. So we can, in building sectors, we can think of making buildings not net zero energy, but net zero carbon. So wherever it's possible to reduce harmful environment effects and reduce the CO2 emissions, we can go for it.
Dr. Bhatia, this may be perhaps the last question, though I'm seeing it, the screen is getting flooded with the questions. This may be the last question. I know that you would have definitely the engagements, for this afternoon. This is a question coming from Mr. Muhammad Siad PS, who is wanting to know, and to quote him, he says, sir, we have already buildings, not plans for the new ones. How to convert the existing old buildings to achieve the green campus?
Yeah, so today whatever I discussed, these are the features that you can easily adopt. I didn't touch the design part. It's the retrofitting part. Like you can easily paint your roof with the white paint. If possible, you can replace the glazing system with efficient glazing system. Installing a lighting system, you can install the LED lights. The low flow water fixtures that can be installed. At the entryway of the building, fresh air system. So different points that are possible for the retrofitting. Today we discussed most of that.
Thank you, Dr. Bhatia. Dr. Bhatia, I would like to firstly take your permission, because we are already through with our committed time, because I could see that there are 3 or 4 of the attendees who have raised their digital hand. Can we take a 5 minutes of yours?
Sure.
5 minutes, yeah. This is for Mr. Amardas, who has raised his digital hand. I'm just going to, I have unmuted you, Mr. Amardas. You have raised your digital hand, requesting you, because of paucity of time, I will just, once again call your name. Mr. Amardas, if you may like to unmute yourself and ask the name, ask the question, please do that. Mr. Amardas is not able to do this. Let me go quickly from A, and now we have Arvind Sahu, who has raised his digital hand. Mr. Arvind Sahu. Mr. Arvind Sahu, I have unmuted you. Could you please unmute yourself and ask the question? This is for Arvind Sahu. Arvind, would you like to do this? I'm sorry for taking your time, Dr. Bhatia, but we just want to ensure, because later on it says that my question was not being taken, so we just don't want to get into that situation. This is from Vidyadhar Das. Vidyadhar Das, you have raised your digital hand, giving you 10 seconds, if you can unmute yourself. Mr. Vidyadhar Das, you have unmuted yourself. Could you please unmute yourself? No, I believe they have got the answers to their queries, because we have so wonderfully have already deliberated and already questions have been asked. This is for Dr. Balveer Sharma. Dr. Balveer Sharma, could you please unmute yourself? You have raised your digital hand. Dr. Balveer Sharma, could you please unmute yourself? On the right-hand side on your screen, you do get this microphone icon. Please click onto it to unmute. Dr. Balveer Sharma. Yes, Dr. Balveer, you got connected, and again, Dr. Balveer, please unmute yourself quickly. You have done it already, and then again you unmuted yourself. Dr. Balveer, this is for Dr. Balveer Sharma. I believe he is having an issue. This is for Dr. Gitanjali Rana. Dr. Gitanjali Rana Kanwar. Dr. Gitanjali Rana Kanwar, could you please unmute yourself and ask the question? Dr. Gitanjali Rana Kanwar, could you please unmute yourself? I believe, because many of our attendees for the first time would be using a platform, and sometimes, they do encounter issues in you have to just, this is for Karthik N. Karthik N, so from A, we have moved on to K, and we have to go till Z to see Karthik N. Karthik, could you please unmute yourself if you quickly would like to ask a question? I'm just about to finish off now. Mr. Reddy Yanam, we have already taken your question from the chat box, and I hope that has met all the queries that you have been wanting to ask to our distinguished speaker. Ramesh Pimple. Ramesh Pimple, could you please unmute yourself? This is for Ramesh Pimple. Could you please unmute yourself? Ramesh, I'm extremely sorry. We can't really keep on waiting for long. Savita Pradhan, Savita, just wanted to tell you, I'm not able to see an audio device with your name against your name, so I can't give you an audio control, because you can post your question quickly if you can. This is for Sunil Mandale. Sunil Mandale, could you please unmute yourself if you want to ask your question? Sunil Mandale, could you please unmute yourself? We would be happy if you have any further questions that you may like to ask. You can always can send us across an email. This is for Vineet Sachin. Vineet Sachin, you can notice, Dr. Bhatia, your talk today has really made everyone they're finding it, they really want to make the best use of your presence, and this has indeed helped in sensitizing everyone. Mr. Vineet Sachin, would you like to unmute yourself? I believe, it's good enough that we would request you can always write to us, and we'll be more than happy to get you connected. I would now like to request Mr. Ratan Jha. So once again, Dr. Bhatia, thank you so very much indeed for being such a wonderful part of the deliberation, sensitizing everyone, sharing so much of your knowledge and expertise with each one of us, and the very purpose of making everyone know about. And you have really made it so simpler. You have, it's like everyone has got something to do. Once they sign out from today's webinar, they do look forward, and they must look forward to implementing some of these green practices in their respective institutions, or for that matter wherever they are, whether they are in their personal spaces or in their professional spaces. They have not much to contribute towards this Green India movement, green institutions movement, and we are indeed much grateful to you for your time and efforts in being there with us, and really so wonderfully deliberating. So this is for Dr. Bhatia, for you from DELNET, and from each one of us, a small memento as a token of our very warm, sincere gratitude to you for being there with us. And we really look forward, this is just a beginning, as I said, we really look forward to working collaboratively and to ensure that, our institutions, we can work on creating a manual for the institutions, as I said earlier, that is for best practices for building up the green campuses. And we can have, our all the stakeholders, all the institutions, we can have deliberations with them. And with your vast expertise in the subject, the institutions would get immensely benefited as the attendees today. And we really want to reach out to more and more through this. So thank you very much, Dr. Bhatia. And it would be a pleasure to meet you here at DELNET, because as we are just across the road, it would be a pleasure to meet you sometime and also to take things further. Thank you very much indeed. I would now like to request Mr. Ratan, who would like to give a concluding remarks to today's webinar. And thank you so much, Ratan, and all the colleagues there in the library and the TERI SAS for all their wonderful support, splendid support in organizing with DELNET this wonderful webinar. So thank you very much, Ratan, and I just request you if you may like to give a concluding remarks. Over to you.
Thank you so much, ma'am. You always is very fantastic. Simply you are very fantastic. You have organized this webinar so nicely. We do not have much word to explain that in detail. So thank you so much, ma'am, for organizing this webinar, and thank you so much, our colleague Dr. Bhatia. They have presented what you have conveyed very simply. In the layman, even they don't know anything about the green campus. If they listen patiently this webinar, they can understand what can we do. The general people and armed people, you can say that. So thank you. Today is very fantastic. Both of us, this DELNET and TERI SAS. Thank you for your DELNET contributions. There's no what to say anything. Everyone know, each and everyone know. Even we are also acknowledged, and our faculty member and the student also acknowledged for that. He always doing the best job, even in our library information science field. So DELNET is doing good job. You especially, ma'am. I don't have much word to tell. We have more than 15-16 years association with you. So simply it is very good. And I also thanks all participant who have attended this webinar. So we will do both together. We'll give more kind of thing. Even we as everyone know, we are not only sir is giving the webinar this green campus. Our all courses, all programs are constructed accordingly. The niche area, we are not a course offered, general course offer in our university. We are in higher education, master and PhD course we have all related to sustainable. We are very committed to sustainable development and SDG 17 goals. Our university has and all programs since map accordingly. So thank you so much, ma'am, once again. Dr. Sangeeta Kaul, Dr. Bhatia sir, so our colleague. Thank you so much. All DELNET colleagues who we have already associated last 20-15 years. Every day we are talking, resource sharing, everything. Thank you all participants once again. Thank you so much. They have essentially listened everything, all information. Maybe we'll get more, and we are also come more information all up to them. Thank you so much, ma'am. Once again, thank you so much.
Thank you, Ratan. Thank you so very much. Thank you. And we would like to convey a very big thank you to each one of our very engaging attendees over here, our own library and information science professionals, our administrators from the various institutions, not many, each and every one of you who really holds a great interest in the areas of bringing in a change, a greener change that all of us are wanting. And it's indeed a proud privilege for us in having you, and thank you so much for deliberating so wonderfully, also for the questions that you have. And that's the things that we always appreciate and admire, that it's not a one-sided communications. They remain as the most engaging, the bi-directional dialogue, and this webinar has been able to generate the much desired interest in each one of us. And you have also given us an opportunity to think about coming out with a publication, coming out with a manual, which will be having a very everlasting effect, on each and every one of the institutions, administrators. It would be a ready reckoner for any institution who would like to embrace and make their, institutions as the green campuses. So we remain truly appreciative of your presence here today, and we really look forward to having you back again. So thank you very much, Dr. Bhatia, once again. And Ratan, before I forget, we do have a small, a moment for you too, as a coordinator for this webinar.
Thank you,
we
ma'am.
truly
Thank you,
remain
ma'am.
appreciative. We truly remain
Thank you.
appreciative of the efforts that you have put in. So thank you so very much, each one of you. I would also like to convey my thanks to my own colleague, Mr. Kushal Giri Goswami, who has been coordinating our webinars from here, and also Mrs. Ranjana. So thank you so very much once again, Dr. Bhatia, for your time. It has truly been a great honor and pleasure, for privilege for us in having you today. And thank you so very much for making this afternoon a truly an enriching and an exciting afternoon. And we really look forward to working together on many more projects, between DELNET and TERI SAS, which will really hold a great significance and relevance to the institutions in the country. So thank you very much once again. Thank you very much, Dr. Bhatia. Thank you very much, each one of you. So we wish you the best of the times ahead, and we wish you the most enriching and informative times too at the same time. We look forward having you back again in the future webinars of DELNET. Thank you very much for joining us today. We have truly, truly valued the presence of each one of you with us today. Thank you very much. Thank you. Namaskar. Thank you.